guys can see.
Good. How many of us now? I cannot see that one where there's the information just now.
Total of 40.
Huh?
Total of 40 people here.
40. Okay, we can start now. Okay. Okay, let us start our session with a moment of silence, remembrance of our God. Al-Fatihah. Okay, yesterday we have looked into the diagram of the plastic bending. How's the length of plastic? How do we calculate the length of plastic? Okay. So these are the example yesterday. That's why we have to draw. There's one very big, the thickness is very high because we want to draw the profile. So this is the point where the critical point. Whatever diagram of moment, the diagram of moment must be like that. Whatever the distance it is, correct? Are you with me, guys?
Yes.
Okay, whatever the distance it is, that one, just the value of moment in terms of P is different. So when it is start of plastic, so this is the point of plastic. Because start of plastic, that moment must be moment maximum elastic. Are you with me, guys?
Yes.
So when that is happening, what happened there here? Only one point of plastic is there. This diagram, you must understand how to draw this one. You don't understand this diagram, the other thing is just rubbish. Not the other thing is not useful, but your understanding is not complete. Okay? So when this is, let's say the moment here is 12. Okay? For polyplastic, the diagram like that. This is fully plastic. Maybe for separa plastic somewhere there, let's say we take a value there. So let's take a case for separa plastic. I don't draw it together because messy. It's messy. Let's say the moment here is separa plastic. Moment separa plastic, let's say the value is 14. So from here to here, I know that this value here is 12. This value here is 12. What does it mean 12? Start of plastic. So start of plastic. Start of plastic there. Start of plastic there. Here, start of plastic there. When it is 14, that one, we can calculate how how much thickness, T thickness, how much thickness, we know that one. From the diagram of that one. Separa plastic, we know the thickness of that one. Are you with me, guys?
Yes.
That one we know. Once we know that one from that diagram, so this is the how much that one. Let's say this one is 12 mm. 12 mm there. So this is how you draw that one. This is a case separa plastic. The length of that one you can calculate. The length of that one you can calculate. Same thing with the top one because symmetry, bottom and top. This one symmetry there. This one symmetry there. And this is how you draw the separa plastic. Are you with me, guys?
Yes.
You know the L1, how much the LP there, how long is the LP during that loading, and that P relate with the P, what is the value that to make that 14? That's how you understand the whole thing there. You finish, that's para plastic. I increase more when it's fully plastic. How does it look like? Don't draw it together because it's messy. When it's fully plastic, draw a different case. Draw a different diagram. Don't do it together. It's messy. For fully plastic, what happened there? For fully plastic, this diagram is fully there. This diagram is fully there. So there must be a different graph there. That moment here may be moment fully plastic. The value may be, I don't know, 17.6, maybe 18 or whatever. Yeah? Let's say 18, 18.4, fully plastic. Let's say. If 12 here, if I know that is square, 50%, 1.5. Lambda, 1.5 of 6. 6 plus 18, exactly 18. I know that. Exactly 18, fully plastic. So this diagram there, when this is fully plastic there, what happened here? What happened there? This is tensile. This is compression. This line here are fully plastic. This one, fully plastic. Tensile, compression. But where does it start plastic? Here, the 12 here, find there, go there, go there, go there, go there. So this diagram should be like that. Are you with me?
Yes.
This is how you draw it. How you find everything there. You cut section here. What happened to the diagram there? Just one layer plastic there. Cut here and here. If cut there, what happened there? If you cut there, what happened? Separate plastic. Some are plastic on the top, some are plastic on the bottom. Cut there, bigger. The plastic is much more bigger. Plastic much more, the area is bigger. Cut there, what happened? Fully plastic. The whole thing is plastic, up, bottom. Are you with me?
Yes.
This is the whole thing. You must know how to. Okay. This is the whole picture here. These are the whole picture here. Now come how you understand wording. Let's say the question is play around with wording, language. Some of you do not understand the language. You just know how to draw. The language you don't understand. Some of you, I have detected so many people. They are not really concerned about language. They just concerned how to do the soft things. Let's say I put a question to make you understand the language also. Can you do it? Okay. Let me show you. This is what question is all about. To test your ability to translate what you hear, what you read into understanding. Yeah? Let's say you have a graph just now, like that. Yeah? Like that. And then the moment graph is like that. Let's say this is 1 here, 3 here. So this must be 1 over 4p. This must be 3 over 4p, correct?
Yes.
And then what is the value of moment there? Can you detect very quick now? What is the value of maximum moment there?
3 over 4. 3 over 4.
P. It's not just 3 over 4. 3 over 4p. How you get the value that one? That load time distance. That load 1.4p time that distance 3 there. So the moment here is 3 over 4p. Very simple. But how many of you realize moment is force time distance? Forget, right? Previously, you understand moment is first time distance, but you come to this graph, you are struggling to find this value because that one times that one. You forget about the first time distance. Correct me not? Is that true?
Yes.
This is what happening. Okay. 3 over 4p. Yeah? This 1 meter. Let's say my moment fully plastic is 18 kilonewton meter. Moment maximum elastic is 12 kilonewton meter. So 1.5, that one 18. So no problem, just nice. With the size that one, that we got that value. Yeah? Now come the question. My question say, if this is point A here, this is point A, this is point B there, point C there, A, B, C there. Yeah? If the question say, this is how can you transform? You understand the whole process now, but can you transform it into your intelligence to put into diagram? The question say, if the loading is like that, if at point B dot somewhere there, which is 0.1 meter to the right of B. Point B dot is 0.1 meter to the right of B. What is the point? Somewhere here, right? This is 1 meter, this 0.1 somewhere there. That is B dot, right?
Yes.
That is I asked you from the beginning. But from your reading here, can you get it? That point. That point is 50% plastic. Not the B point. B dot point is 50% plastic. How do you conclude from that?
The plastic area for B is higher than B prime.
It's not 50% at B. At B dot is 50%. At B must be higher than 50%, right? So can I find how much B is plastic?
Can.
Yeah. So how do we do that? I go back. This is how do we do that? It's all about your intelligence. But before that, it's all you are talking to yourself. Do you have that ability or not? This is what most people who just study by memorizing the technique in Form 5, you'll never solve this problem. Because you don't have a thinking skill to go to the new process. You haven't seen this problem before, you cannot do. And that is Form 5, ability of Form 5. That's different between university and high school. University, you give a new problem, you can think. Are you with me, guys?
Yes.
This is what most of you give a new thing that you cannot see, you haven't seen before. You just do whatever you have done before. Cannot go beyond it. This is the purpose you come to university. You must go beyond things that you haven't seen. Because you study the fundamental and you can go on your own of the new problem. How do we solve it? We are talking to ourselves. How does engineer solve this? They are talking to themselves. Oh, this one is the moment here in terms of P. The moment here is 3 over 4P equal to 0.75P. Is that true? I ask myself, is that true? Oh, yes. Force times distance. This is 3 over 4P times 1. Also become 3 over 4P. This is 1 over 4 times 3. Also become, by that method, is also become 3 over 4P. Okay, this 0.75P. If that is 50% plastic, I can calculate it. Maybe the 50% plastic is, this is 100% plastic. Correct? Fully plastic.
Yes, correct.
So if I draw the diagram 50% plastic, I got the moment not. Let's say the moment is 16. This is 50% plastic. 16 kilometer meter. Let's say you have done that one. But it's not here. It's not here. Somewhere there. So how do I do that? Your thinking will be talking to yourself. That is 0.5. 0.1 distance from here is that value. Can I, because this is straight line. It's 1 meter there. This 1 meter. I don't know this value, but I can put the A. This is 1 minus A. I know this height. I don't know that height also, but in terms of P, I know that height is 0.75P. 0.75P over A, same with, I don't know that value, that height over A. But that value, I know the distance is 0.1. That A must be 0.9. Is that correct?
Yes, correct.
So, my mathematics say what? 0.75P over 1 equal to, I don't know that height. Sigma at B dot. Not sigma, that moment at B dot. Over 0.9. So I solve this. What is my moment B dot? Please, what's the value?
0.675p.
So this is 0.675P. No problem. Now can I solve things? Yes, I can solve things with that 60% and 50%, but not through this point. I solve it through this point. Can I find the P naught? Yes. Are you with me?
Yes.
I don't have to solve this one. I just draw this one. So that one, maybe the maximum, the starting of plastic here, starting of plastic is there. So this one, starting of plastic, this one, this is 50% plastic. This is 50% plastic, 50% plastic. 50% plastic. So this one must be higher a bit than 50%. So I go to that point and then go that one. I don't have to solve this one because the question doesn't ask you to do that one. The question just asks how much P that one. I can solve from that point. So this is 50% plastic. This is 50% plastic. This may be 55. I don't know, maybe 60. I don't know. I can find it, or if the question doesn't ask you to find it, you don't have to find it, but I can always find it. But through this analysis, to solve that 0 0.675 P is equal to 16 kilonewton meter. Can I solve my P? Yes, that P is also valid for the middle for everywhere to make that shape. Are you with me, guys?
Yes.
You haven't seen this everywhere. But can you anticipate the solution to it if it be asked to you by that point? The other is straightforward. This is not straightforward. It doesn't say here is 50%. Somewhere else 50%. Can you relate it? This one I'm worried. For those who are learning by memorizing. You haven't seen this, you don't know how to do. But if you learn by understanding what is triangle, what is sine theta, tangent theta, there, over there, the same theta, that one. The same theta is that one over one is tangent theta. Tangent theta is equal to that tangent theta. That's why you have that equation. That is required for you to have a grasp on trigonometry. If you don't have a trigonometry in your head, you're just starting to develop trigonometry, you don't even know how to solve it. Idea how to go through it. Are you with me, guys?
Yes, doctor.
Okay. Yeah? You can anticipate a lot of problems by creating your own question. The own question is you go further and further from this. How further you can go, that's how much you are getting on your own. This is just an example. If the information is given, it's not at the critical point, somewhere else. Can you solve it? Okay, So today I want to go a little bit further with the cross section. 2 points I want to do today. 1 point is the different cross section. The cross section is not solid. Let's say we have hollow. Still symmetry, but hollow. How do we do that? Same thing there. This is the same thing. Yeah? But the cross section is like that. Are you with me, guys?
Yes.
Okay. The cross section is like that. Let's say this is 10 mm. Yeah? This is 40. This is 40. This is 10. So this is, let's say here is, this is 30. This is 10. This is 10. This is, that means the inside here is 30 times 80. Outside here is 50 times 100. The inside hollow here, inside hollow is 30 times 80. The outside is 100 times 50. So we have a hollow. Yeah? So how do we solve this one? If it's the case of maximum elastic, separaplastic, fully plastic. So we have to do it very slowly. Are you with me, guys?
Yes.
Yeah. How to do that? For case fully plastic, I'm a maximum elastic. Maximum elastic, the top layer is plastic. So what is the diagram there? Yeah? So this is sigma y. So how can I draw the triangle times that area? Very difficult, right? Where you can put your centroid? You don't know, right?
I don't know.
So what do we do? We break the area into several areas. So I know this one. This is one area there. So we break also here so the triangle becomes trapezium now. Are you with me?
Yes.
That is 200. So that is 10. That is 40. Can I find that length? Can I find that length not? That length here. What is sigma there?
Can. Similar triangle.
So what's the value there?
Eh,
Can you do that on your own?
can.
So what's that? 200 divided by 50 is equal to sigma A. Sigma A by 40, right? 250 sigma A over 40. That's the equation. Can you develop the equation on your own to get that one? This is after I show you. Before that, can you do it very quickly? What's the value there? 160, right?
Yes.
160. Now, you see that 200 here and 160 there. You can find the average. Remember the force is force times average, right?
Force time average. Area time average.
Yeah, sigma average times area, right? So to solve that force, that one, no problem. Because 200 plus 160, 200 plus 160 divided by 2, you got the average, not?
Got.
Yes, and the area you got here, 10 times 50, right?
Yes.
10 times 50. No problem. This one is no problem. F1, no problem. But where do you put that F? The problem is, where do you put that F? If there is a triangle, you can put that F. Are you with me?
Yes.
That is 2/3 from that one. If it's square, that is half that one. But now it's not square, it's not triangle, trapezium. Where do you put that F? Problem not?
Problem. Need to combine both.
Yes, how to do that? Now come the question. Where you want to put that F? There must be a point where you want to put that F. The point here, the F here, there must be a distance, right? Where that D you want to put that F? The value is correct. So how to do this? Hello guys, how to do this?
Like can combine the both of the centroid of square and triangle.
Yeah, how? How?
X centroid of the trapezium is equal to centroid of the square times force plus
where
centroid
you
of
want
the
to put it?
triangle plus force.
Where you want to put it? So the answer is, before you can combine it, you break it first. Are you with me?
Yes.
You break the square and triangle. Are you with me not?
Yes.
So this trapezium here is 200 and 160, right? 200 and 160 there, all are act on that area, right? Are you with me?
Yes.
Now I break it into rectangular and triangle. How is that so? This one. Break into triangle and the other one is rectangular. Rectangular is 160 and 160. Triangle here is 40 and 0. Can you see that one?
Yes, can see.
That 40 and 0 here act on that area. That 160 and 160 there also act on that area. So, for that triangle, I know my position of centroid. I have my F1. And then for that square here, I also know my centroid. I have my F2. So, my F1 now become 2F. Are you with me?
Yes.
That's the idea. you break into two area that you can solve. But the value is not 200 anymore. 40 and 0, 160 and 160. Can you see that?
Yes, can see.
That's the idea. Very important point. It's not about 200 anymore. Yeah? So I also gave the triangle here, add on that area and that area. So no problem, because that area plus that area is square, right?
Yes.
So 10 and 10 here and height 40, so no problem. That central here also have only one F3 only. So only top one I break into two, the second one triangle and square, no problem. So I have what is my F1? 40 and 0. See that? Sigma average times area. So what do we have there? 40 plus 0 over 2. Everybody, are you with me?
Yes.
The others, are you with me?
Yes, doctor. Yes.
Yes, doctor.
Very important here. Nothing to do with 200 anymore. Yeah? 40 and 0 plus 2 and the area. The area is 50 times 10. 50 times 10. So milli and milli cancel. Mega. So we got a value Newton first. And what's your D1? D1, I know that 40 here and that is 2/3 of 10. So 40 plus 2/3 of 10. This how you write here show your understanding. And then what is your F2 there? F2 is here. That one. From that square here and that square here. The square here is what? 160 plus 160 divided by 2. Average, 160, 160. And the area is still the same with that one. 50 times 10. Are you with me, guys?
Yes.
And then what's your D2 then? Your D2 there, that one. 40 times half of 10. 40 plus half of 10. Very clear, that one. And then what's your F3? F3, 160. Not 200 anymore, 160 and 0. So F3 there. Can you see that my writing F3 there? F3 is, that one is 160 plus 0 over 2. Sigma average time area. Sigma 160 and 0 there. So the average is 160 plus 0 over 2 times the area. The area is 10 times 40. 10 times 40. So 20 times 40, correct? Add on the same area. So 20 times 40. Can you see that? How 20 times 40? Because this is 10, this is 10. So become 20 times height, 40. Are you with me, guys? Even though
Yes.
it's left and right, but the same stress is acting on that area. And both area, that one, if the area is not left and right just like that, 20 and 40 is all the same. Are you with me?
Yes.
You must understand it. What is that? 20 times 40, that one. So you got that one. And then what is your D3? 2/3 of 40. Correct?
Yes.
So you can calculate it. So you can calculate the moment maximum elastic, not? Yes. Moment maximum elastic, what is that? F1 times D1 plus F2 times D2 plus F3 times D3 times 2, because up and down here. There must be another one there. Yeah? F3, F4, F5, F6. Are you with me, guys?
Yes.
You can calculate it. So if it is paraplastic, the same case. Fully plastic is easy. Fully plastic is easy. Why? Because square and square, no problem. Fully plastic. Fully plastic. So you break. I cannot that one time the area. So break into the area. 1F. 1. And then that 200 and 200 times that area. So another F. Very easy. Are you with me?
Yes.
Fully plastic is easy but you have to still to break because you cannot find the centroid of that area. But you break that area, that one you know. That's fully plastic. Separa plastic. Okay, separa plastic, the same thing. You have to do it slowly. Break the trapezium into what?
Into the section we know.
What is that? Triangle and?
Simple triangle, square, rectangular.
Yes. Why is that so? Because we have to find the correct distance, D, to put the F. Where is the position of the F? Let's see, this one. Yeah? Let's say this is plastic. This is plastic. So how do we draw it? Slowly. This is 200. Up until there. 200. And then from here to here, elastic. Up until there. Okay? Nice. And then we break into area. This is one area. One area 1. Area 2, that one. We have to break into 2. Trapezium, that's another force 1, no problem. And then this one area bottom here, elastic, and elastic here, we have to break into 2. F2 and F3 there. Trapezium here become triangle and square. All act on that area 2. And then area triangle here act on that area, we have another F there. F4. Can you see that?
Yes.
This is how you do it slowly. Are you with me?
Yes.
If the plastic is more than that thickness, so what do? Slowly. Let's say the plastic is up that one. This is middle there. So this is plastic. So what do? Slowly and slowly do it. The diagram there. Up until here, plastic. Then elastic there, up until there, plastic. So this one and that one, no problem. There must be F there. So this one and that one, very difficult. Break into 2. So there must be 1 F there. And then there's another 1 F there too. But very easy. Are you with me, guys?
Yes.
That's how you work on this. For the case, this is, we have a still symmetry but a hollow area inside. Are you with me?
Yes.
Okay. Now, I want to another topics. So we have to run very quick, okay? We have another 2 more topics to finish before end of this semester, okay? We have to be able to very quick. Okay? What is the other topics about this one that we have to go today? What if we reverse it? Yeah, I show you on the cross section that is not solid, right? Already done that one. I'll show you how to relate with the loading. How to find the P also, right? We have done that also yesterday. Now, how do we reverse it? Okay. We have done this. We have done this before. P, the one, the cross section, the one. Let's say go with the cross section that is solid again. To make you understand. We have done yesterday, what is the size that we have known? Give me the size that we know yesterday that we don't have to calculate anymore.
For question A lah, 40 and 100. Yeah.
40 and 100. Okay, sigma y is equal to
200 megapascal.
200. Moment maximum elastic is equal to what?
13.3 kilonewton meter.
13.3. And then moment fully plastic,
20 kilonewton meter.
20 kilonewton
Meter.
Okay. 13.33 and 20. So have we calculated somewhere in between?
50% plastic.
Okay. 50% plastic, what do we have?
50% plastic. Our moment is 18.3 kilonewton meter.
18.3, right?
Ah,
18.3 is 50%, right?
yes, 50% plastic.
Yeah, we have done that calculation, correct?
Yes.
Yeah. Now, look carefully here. This is 50% plastic. 25, 25, 25, 25, right? We have 40 times 100, right?
Yes.
So through this, we draw the diagram. We draw the diagram there. We draw the diagram. The diagram must be like that. There's another F there. There's another F there. Is it correct?
Yes.
Okay? Is that correct, yeah?
Yes.
F1 and F2, you got 18.3, right? So you decide that is 50% or 25 mm. On the top, 25 mm. From the bottom is plastic. And then you draw that diagram and you got value 18, right?
Yeah, yes.
18.33. Now, can we reverse it? Can we reverse it? Let's say my moment is, it is paraplastic. I know it's above 13 and below 20. My moment is equal to 15 Newton meter. How much plastic is this? This is what I call reverse case. Can we do that?
Can.
Can we do that?
Can.
Yes. This is what the topic of our working now. So, how do we do that? I don't know my height, right?
Don't know.
But if that is A, what is this?
50 minus A.
Yes. This is 50 minus A, that is A. So, that is A, this is 50 minus A. So, this is 200, 200, this is 0, right?
Yes.
This is A, 50 minus A. So, what is my F1? Sigma average time area. What is my F1 at? 200, 200, right?
Yes.
200 plus 200 divided by 2 is 200. And then your area is what? 40 times A, right? Now your answer in terms of A. Are you with me?
Yes.
What is your D1? Center right there. How to get there?
50 minus A times.
50 minus A
A.
plus
Half of A.
half of A. So your answer is what?
50 minus half of A.
50 minus half of A. So your answer is also in terms of A. Your F in terms of A, your D in terms of A. And the same thing with your F2. Can you do that in terms of A? Can you do that D2 in terms of A? Yes. F3 also 2 only. So for symmetry here, jadi F1 times D1 plus F2 times D2 and then times 2. That one is equal to what? This one times 2. That's one equal to what value is that?
Moment of separa plastic.
This one, to answer your question. Are you with me?
Yes.
Moment separa plastic is the FD times 2, right? And the value is 15. I want to find your A. Inside here, there is A, there is A there. Can you solve your A from that equation?
Can.
Yeah, that's how you solve it. The thickness. Reverse of the work. Are you with me, guys?
Yes.
So 2 to D. One is cross section is not symmetry and that's not solid. How to do it? Trapezium become square or triangle and rectangular. The other one here is a reverse case. I know my moment. How much thickness is that? This is how you solve it. Are you with me, guys?
Yes.
You solve that in terms of unknown. The diagram there must be one unknown there. If you put that A unknown, this must be 50 minus A. Because you know that 50. You solve that in terms of the unknown. Are you with me, guys?
Yes.
Okay, thank you very much. That's our point for today, for this weekend. Okay? I give you some